In this video, we're going to be deriving the major trigonometric identities using three basic equations, arguably really just two fundamental equations. So without further ado, let's get cracking. Okay. So first of all, we'll build some basic intuition. We'll draw a circle and place that circle at the center of an XY coordinate system. Now, trigonometry is all about, well, in the way that I perceive it, it's about using right triangles to locate points around the circle, simply stated. So if we choose an arbitrary point, let's say a point here, and we draw a line from the center of this circle to that point, okay, we can establish a few basic truths. Okay. This line from the center of the circle tangent to a point on a circle, that's the radius of the circle, and we'll use the symbol R for radius. If we drop perpendicular reference lines onto the positive x-axis and then onto the positive y-axis, and we see that we formed really two right triangles. Okay, so you have a right triangle here, and you have a right triangle here. So it's just a rectangle that's divided along the diagonal, forming two right triangles. Okay, the radius, as it rotates, okay, we denote the position of this point in space. The position of this point in space is given by x and y. But also, we can also locate that point using the radius and the angle. So the angle gives us the position, the angular position at any point along the circle. So these are just two different ways that we can look at finding the position or location of that point, right? And this can be transformed, right? You can go from the XY coordinate frame to the polar coordinate frame. Okay? So these are what's referred to as polar coordinates. And these are your standard X and Y coordinate system. Okay, so with that, the length from the center to this point, right, is x. Okay, so we'll label that side, or the base of the triangle, we'll label that x. Okay, and then the length from here to here, the distance from here to here to locate this point using the XY coordinate frame, that's just equal to y. That's just equal to y. So we have four variables, and these four variables can be expressed using these equations. Okay, so r squared equals x squared plus y squared. Okay. And if we want to relate the sides of the triangle to the angle theta, we use the sine and cosine function. So the sine of theta, the sine of any angle, is just the opposite over the hypotenuse. So in this case, the opposite side is y, and of course the hypotenuse is r. All right, the ratio between the length of side y and the hypotenuse r. Okay. Now, arguably, right, these two equations are really all we need, because we can derive the other equations, the other trigonometric identities from these two, because if we know sine, we know cosine. Okay. So the sine of the angle is equal to the cosine of pi over 2, which is equal to 90 degrees, minus theta. Okay, and we could just call this angle alpha. Okay, So this angle will say alpha. So if we know theta, we can determine what alpha is, and we know that this is a 90-degree angle there. Okay, that by definition, that's what makes it a right triangle. Okay, so arguably, if we know sine, we know cosine. Okay? So the title says 3 fundamental equations, 3 basic equations, but on a more fundamental level, it's really just 2. You know one, you know the other. And also, cosine, the co just means the complementary of sine. Okay, so cosine is the complement or complementary angle, right? These 2 angles have to add up to 90, right? Alpha and theta and omega have to add up to 90. All the angles of the triangle have to add up to 180. So if we know that this angle is 90, then theta plus alpha have to equal 90, right? And that'll equal 180 degrees, right? So if we want to find alpha, let's rewrite that over. We just subtract theta from both sides. Algebraically, we get cancellation here, say alpha is equal to 90 degrees minus theta. And that's what we showed earlier. Okay, moving on. So we have all of the equipment, all of the mathematical equipment to begin the derivations. All right. For the cosine, if the sine of an angle is equal to the opposite over the hypotenuse, then the cosine is equal to the adjacent side over the hypotenuse. The adjacent side just means next to. So since this side, bring that beat back. Since this side here is adjacent to this angle, okay? That's the adjacent side. And of course, this side is going to be opposite of that angle. It's looking opposite side to the angle. All right, and here we go. So first thing we're going to do is solve for y and x. Okay, so when we solve for y, we get r sine theta. Because we multiply each side by r, it cancels on the right, and then we're left with r times sine theta on the left side, and then we just reverse the order. And we do the same thing for cosine. So the cosine is equal to r cosine theta. Okay, let's rewrite the equations. R squared equals x squared plus y squared. Let's let r equal 1 unit of length. When we set r equal to 1, just 1 squared is just equal to 1, and then the rest x squared plus y squared. Okay, so we don't have to put the square there. 1 squared is just 1. Okay, but I'm being very explicit. This noted is also the equation of the circle. If you go to a graphing calculator and type in this equation, it'll give you the equation of a circle at the center, because this is placed at the center of the XY reference frame. Now we've already solved for x and y, and we've already set r equal to 1, right? So again, if we let r equal 1 here, right, it's just going to be y equals sine theta. And same thing, we let r equal 1 here, we're going to get x just equals cosine of theta. And we can plug that into this equation here, and then we'll arrive at our first trigonometric identity. So let's replace x with cosine theta. We get cosine of theta squared, and then we'll replace y with sine of theta. We'll get sine of theta squared. And we'll rewrite this as cosine squared theta. Same thing. This is just the way it's denoted in textbooks. And we have sine squared theta. So that gives us our first trigonometric identity. Let's go a step further. Let's solve for cosine squared theta and sine squared theta. Okay, so when we solve for cosine squared theta, we get 1 minus sine squared theta. Because we subtract sine squared theta from both sides, it cancels out on the right side, and we're left with 1 minus sine squared theta. Okay, and then the same deal, let's solve for sine squared theta. When we solve for sine squared theta, we're going to get sine squared theta equals 1 minus cosine squared theta. Okay, we can go a step further. We can divide 1 equals cosine squared theta. So that gives us our 2, we're up to 3 identities. Let's rewrite the equation again, and we're going to divide everything by cosine squared theta, and then we'll divide everything by sine squared theta. Okay, so we divide by cosine squared theta all the way through. 1 over cosine squared theta is secant squared theta. So secant squared theta is the reciprocal of 1 over cosine squared theta. Cosine squared theta divided by cosine squared theta is just 1. Sine squared theta divided by cosine squared theta is just the tangent squared theta, because sine of an angle divided by cosine of an angle, we write this as just tangent of an angle. So we don't have to write sine of theta over cosine theta. This is just like shorthand. Okay? But it also serves a very important function, tangent. Okay, and then lastly, we're going to divide everything by sine squared theta, and we'll get our 5th identity. And then we'll stop there and we'll move on to the next video. And then I'll reiterate these things. I'll review them, overlap them in the following videos. So make sure these are watched in order. So if you divide everything by sine squared theta, okay, we get the following. Let's move this one over. Put this one in pocket. Move it down here. All right. Okay, so 1 divided by sine squared theta, that gives us a reciprocal identity called cosecant. And I like to write cosecant like this because if you look at the 3rd alphabet, that is also associated with sine, right? And you can do the same thing with the secant function, right? The secant function, the 3rd letter is C, and cosine starts with C. So it would be intuitive if cosecant was related to cosine and secant was related to sine, but it's the opposite. So that's one way that you don't get tripped up by that. Okay, and this is equal to cosine squared theta divided by sine squared theta is the inverse of 1 over tangent squared theta, and we call that the cotangent. Okay, so tangent is sine over cosine. So the cotangent is the reciprocal of the tangent. And then sine squared theta over sine squared theta just equals 1. Okay, so this was our 4th, and this is our 5th identity so far. Okay, and we'll continue in the next video. So stay tuned, more to come.